We're going to try another covalent compound, and we're going to deal with one between nitrogen and hydrogen. So if we take a look at the periodic table, hydrogen has 1 valence electron, nitrogen has 5. I'm going to draw them around, and of course I'm going to put nitrogen back into the middle again, so it is easier to draw the compound. Alright, so similar to what we did with carbon, hydrogen wants 1 more electron in order to fill its octet. So if I were to share an electron with this nitrogen, I'll be able to create a bond, a covalent bond, and that covalent bond allows the sharing of the 2 electrons around hydrogen, making this a stable atom. Nitrogen still at this point only has 2, 4, 6 electrons around it. I need to do this 2 more times. So I'm going to put a hydrogen here for sharing and a hydrogen here for sharing. Each one of these creates a new bond. Surrounding nitrogen now, I have 2, 4, 6, 8 electrons. It's happy. All the hydrogens are happy. This is the molecule that's going to be created in its most basic form between nitrogen and hydrogen. Please notice that there is one part of the nitrogen that the electrons are not actually bound to anything. So there's 2 of them sitting here on the nitrogen that aren't involved. And what we call this, since it's a pair of electrons, we actually call this a lone pair of electrons. So if you ever hear us refer to that, it means it's a lone pair of electrons. Let's take, for example, chlorine. If I had chlorine and I created a bond with another chlorine atom like this, this one chlorine atom has 1, 2, 3 pairs of lone pair of electrons. So 3 pairs of lone pair electrons around this chlorine, and this chlorine has the same thing. So these are electrons that typically at the moment are not involved in any sort of chemistry, but in some sort of future chemistry they can be used, they can be exploited. These are free electrons that are ready and available for a reaction.